Okay, now we're going to talk about concatenating and stacking arrays. So often you might want to combine data from multiple arrays. So you might get like a slice of data. So for example, for our depth sensor, every tenth of a second, we receive a new slice of data that lists the depth for our field of view. So what's returned is a 2D NumPy array. And so if we want to create a video, we need to concatenate all of those frames together over the course of the entire experiment. So concatenating and stacking arrays is a very common thing that you might want to do. So there are a number of different approaches, and we are going to cover 3 different ways that you can combine data together. So each one has kind of their own unique pros and cons, and so it's good to know all of these approaches in order to combine data. So the approach 1 is to create a new array and replace the data with existing data. So if you know ahead of time how large the data will be, it's often easiest just to create a brand new array of the proper size, and you initially set the value of the data to 0. And then you take all of those slices of data that you want to combine and you replace the zeros with the data within there. So let's see how this works. So as a one-dimensional example, let's create 2 different arrays. And so we have 2 different arrays of value, and both of them have a length, a single dimension, and a shape of 4. So what we want to create is an array that has both of these arrays together as different slices. And so we can do that by creating a new array that is the proper size. So we've seen before how to create a new array, and this is filled with zeros. So we've got our array. This is going to hold all our data, and now we just need to be able to add the data from A into it. So, it's always useful to kind of mess around with it. So this is kind of why I always go to the interpreter when I'm trying to figure out how to do things, because it's always useful to make sure you have the right slice, for example, and the indexing in order to actually get the data that you want. So in this case, the first axis is the rows, and so if you want to access the entire column of data, you have to do something like this. And so this gives us that first column of data. We say return all of the data, and we want the 0 element from each one. And so now we can simply set that first slice of the data to the value of A. And it's important to copy the data, so you probably want to copy the data, make a brand new copy of the data, because otherwise if you modify A, you modify C, and if you modify C, you modify A. And so this is just that deep copy that we talked about earlier on with lists, and this also is true for NumPy arrays as well. So now you can see we sent that first slice equal to the value of A. And so you can see if we look at that first row, now it's equal to 5 and 0. And if we want to see that first column, then everything looks good. And then if we want to set that second slice, the second column, equal to the data of B, then we can do that very easily. And so we've created a new array C that has the data from A and the data from B in it. And you can certainly do this with more than one array at a time. So if you wanted to create an array that had 16, and so then you could potentially combine 16 different NumPy arrays together into this single array of dimension of shape 416. All right, that's the first approach. So you create a new array of the right size, and then you replace those values with the values of the arrays that exist. The second one is to use concatenate. So we are going to see how this concatenate function works. So this is a function of NumPy, and what it takes is a list of arrays. So we provided a list of all the arrays that we want to concatenate together. And so in this case, we are going to provide it with A and B. If you had more data, if you had 16, the length of the list could be as long as you want. So this is flexible to combine more than 2. But you can see how this works is that in this case, the way it concatenated the data is that it created a new array of shape 8. So instead of creating the data in a new axis, a new dimension, it concatenated them together along the existing axis. So this is how concatenate works. Concatenate can only append data together in existing axes. So it can't create a brand new axes in order to combine the arrays together. But this can be very useful depending on how you want to combine the data. So sometimes you might want to create a new array that's a size 8. So if that's what your goal is, then that's what you can do. And you can specify the axis that it is combined on. And we can see that, and then if we try to combine here, we get an error because, and then again, that's because this axis right here, that second axis right here, doesn't exist. So let's see how this works on two-dimensional arrays. So we're going to create two-dimensional arrays, so C and D, and we can see that the shape is two-dimensionals. And so now what happens if we concatenate these together? So one of these ways is to concatenate it in this direction, so vertically. So you can see that what we created is a 4x3. And then if we want to specify a different axes, we can combine them horizontally, and so now the shape of that is equal to 2, 6. So there's kind of two different ways that you can concatenate these arrays together once they're two-dimensional, either horizontally or vertically. And again, if we try to create a new axis, we unfortunately cannot do that using concatenate. We get this error, this axis error, so this is out of bounds. All right, the final approach is to combine data along a new axis. So you can use the stack function for that. So as an example, so we have A and B, and so if we concatenate these together, we get a new array of length 8. But what we're trying to do is create an array that is a 4x2. And so if we use stack, so very similar to concatenate, where we provide it with an array, a list of the arrays that we want to stack together. And so now we see that these are stacked in this brand new dimension. And so we can see the shape of this is a 2x4 right here. Similarly with the two-dimensional arrays. So now you can see that we've created a 3-dimensional array. And you can see the shape is like this. So stack is useful for when you want to create a brand new dimension in order to combine the arrays on. And you can also continue to do this with 4-dimensional. So if you combine two 3-dimensional arrays, you can potentially create a 4th-dimensional. So it all kind of depends on what exactly you're trying to do. Sometimes it's more appropriate to concatenate arrays together. Sometimes it's more appropriate to stack together, stack arrays together. But this is kind of the approaches that you take in order to combine the data.